Page 10 of Polynomial Models bookwork. This is similar to the previous two problems we did with the boxes. This box, the only difference from before is that it's not a square bottom. It is a rectangular bottom. So the bottom is x by 2x. And then the height is y like before. Okay, and the volume of the box is 300 centimeters cubed. Write an expression for the volume of the box. You guys are experts at this now, right? So volume equals length times width times height. So it would be x times 2x times y is equal to the volume, and the volume also happens to be 300 centimeters cubed. Okay. Then it says, that's A. B, find an expression for the surface area of the open box in terms of x only. Okay, so it's not too hard to find the surface area. The surface area, if we draw like each part of this, we have basically, we have three different, we have this red part, we have this orange surface here, and then we have the bottom surface, right? So we have these three different types. The green surface, since it's an open box with no top, so that means the bottom, which is 2x times x, there's only one of them. Okay, and the orange part, there's two sides, so I'll say plus 2, and each side of the orange part is 2x times y. 2x times y. And then the red part, there's two of those, and it's just x times y. Okay, and so this is the total surface area of the box. The top is open. So the only thing that we need to do now, which they asked for, is to put it in terms of x only. We have y's here, we have y's here. How do we get rid of the y? Well, we can take this and make an expression that is y in terms of x. We could say that y is equal to 300 divided by 2x squared. So we could put that in. Every time we see y, we could just put that in there. So we'll have surface area equals 2x squared plus 4x times y, which is 300 2x squared, plus 2x, and then again 300 2x squared. So now we have an expression for the surface area, which is in terms of x only. So that's B. Now use the GDC to sketch the graph of the area function from 0 to 20. Okay, find the dimensions that make the surface area a minimum. Okay, so we could simplify this, but we don't have to. I'm going to just simplify it just to show you what it looks like when you simplify it, but if you wanted to, you could just put it in the calculator like this. 2x squared, that's already as simplified as it gets. 4x divided by 2x squared, you can cancel the x with one of the x's in the bottom. 2 you can cancel with one of the 2's here, so you would get, and you don't worry if you don't understand it, so you could just put it in as is in the calculator. We'll just put plus. So 4 times 300 would be 1200. Divided by 2 is 600. 1x. And then 2 times 300 is 600. Divided by 2 is 300. Divided by x. So this is actually equal to 2x squared plus 900 divided by x. Because if you have 600 times 1 over x plus 300 times 1 over x, you can add those up and you get 900 divided by 1 over x. Okay? So we can put this in the calculator, 2x squared plus 900 over x. So let's do that. So we'll put y equals 2x squared plus 900 divided by x. And then we graph it. So I'm going to put the window to be x from 0 to 20 because that's what they ask us to graph. For the y, I'm going to put from 0 to 1,000. And this is what I get. So if I draw a sketch of that, I would draw kind of like that. And then it says, find the dimensions that make the surface area minimum. Well, it looks like there's a point somewhere around here that the surface area is as small as possible. So let's use the second calc minimum function to try to find where exactly that is. So first we go to the left of that point. Enter. And then we go to the right of that point. It's already starting to rise. And then we say whatever guess. So the minimum is at x equals 6.08. So x would be 6.08. 2x, which would be the other side of it, would be 12.16. And the height y is equal to 300 divided by 2x squared. So that would be, let's calculate that, 300 divided by 2 divided by x squared, which is 6.08 squared. 4.06. So the dimensions of the box to make the surface area minimum are 6.08 times 12.16 times 4.06. Okay, now for the last problem. A pyramid has a square base of side x meters. The perpendicular height of the pyramid is h meters. The volume is 1,500 meters squared. Find an expression for the volume of the pyramid using the information given. So I made a little drawing here for you so for you to imagine what the pyramid looks like. So a pyramid has a square base in this case, and then from each corner it rises up to a point. Okay, and I just made this one out of a transparent material so that you can see inside, because we need to talk about what this triangle in the middle has to do with it. Okay, so the two formulas you're going to need to do this problem are the volume of a pyramid, which is 1/3 length times width times height. And in this case, length times width, since it's a square pyramid, this is x and this is x. So it would just be volume equals 1/3 times x, which is x squared, times the height, which is h. Okay, and the height is just this vertical bar right here is the height. Okay, so that's the height. The other formula you're going to need is Pythagorean Theorem. X squared plus y squared equals hypotenuse squared. So the first thing it asks for is find an expression for the volume of the pyramid using the information given, and we just did that. Volume equals 1/3 x squared times h. Now it says, show that the height of each of the triangular faces is, and there's this complicated expression here. Okay, now when they say a triangular face, what they mean is one of these diagonal walls, and I colored this diagonal wall green for you to see what they mean by that. So do you see how this triangle is a triangular face of the pyramid? Okay, the green triangle. So they're saying, what is the area of this green triangle? And to figure out what the area of this green triangle it is, we need two things. We need the height, and we need we need the base, and we need the height. And the height of this green triangle is kind of difficult because it's a diagonal length, right? The height of the green triangle is not the height of the pyramid, which is totally vertical. So how do we find the height of this green triangle? Once we find the base and the height, then we know that the area of a triangle is 1/2 base times height. But how do we find this height here? Well, the way we find that height is we use this yellow triangle that's inside, okay? If we find the hypotenuse of this yellow triangle, then we have found the height of the diagonal face, okay? So let's draw the yellow triangle right here, okay? And I'll use yellow color here just to represent it, okay? And so I'm drawing like a side view of it. And so the vertical part, of course, is h, which is the height, right? And we know also that this part of the triangle is related to x, which is the length of the side. It's actually 1/2 x, right? So we'll put x over 2 for the length of this leg. And then what about this hypotenuse here? How do we find that? Well, the hypotenuse here is equal to this squared times this squared. So remember Pythagorean Theorem, right? So if we take the height squared plus x over 2 squared, and we add them together, and then we take the square root, that is the length of this diagonal piece here, which is also the height of the triangular face. So if we find this height, or this length here, that is equal to the height of the triangular face, and it says show that the height of each triangular face is this. Well, we just did that, didn't we? We have square root of h squared plus x over 2 squared. So we just did B. Now it says find an equation for the total surface area of the pyramid. Okay, the total surface area of the pyramid. So the pyramid has 4 surfaces. 1, 2, 3, 4, right? It's got 4 triangular faces that are diagonal. And then it's got the bottom, which is like a square-shaped face. Okay, so we got 5 faces, 4 of which are identical triangles. So let's find the bottom piece first. So the square piece is the area is x times x, so it's x squared. And then the triangular face, we know that the bottom is x, and this height is this very complicated expression here, square root of h squared plus x over 2 squared. And if we wanted to find the area of this triangle, it would be 1/2 times x times square root of h squared plus x over 2 squared. Okay, and so that's one of the faces. And then we have 4 of these, right? So we're going to take this times 1, and we're going to add it to this times 4. And that will give us the total area. So the answer to C would be x squared plus, and this will be the total surface area, 4 times 1/2 x times square root of h squared plus x over 2 squared. Okay? And so we could simplify that a little bit. 4 over 2 is equal to 2. So that's x squared plus 2x square root of h squared plus x over 2 squared. Okay? So that is the total surface area. And that is part D. Actually that's part C. Part D says to put the surface, the equation of this total surface area in terms of x only. And so we need to somehow get rid of the variable h, because that variable is not x. Now, remember that the volume of the pyramid is equal to 1500. Okay, so we could relate x squared and h through this equation, right? What if we solve for h using this equation? Then we'd have 1500 divided by 1/3 x squared. And that's equal to 4500 divided by x squared. Okay, so now if we put this in for h, then that would give us an expression that would be completely in terms of x. So that would be x squared plus 2x times the square root, and h squared would be 4500 squared over x to the 4th plus x squared over 4. Okay? And so now we've gotten d. Now it says use your GVC to sketch the graph of this equation for x between 0 and 30, and then find the dimensions that make the surface area minimum. So I'm going to put that in the calculator. Okay, so I typed this expression, x squared plus 2x times square root of 4500 squared divided by x to the 4th plus x squared divided by 4, and I put it into the calculator. Then I graphed it, and I got this. And I'm graphing it from x equals 0 to x equals 30, because that's what they need to tell me to graph from, and I needed to go up to about 3000 on the y. So take a look at my window here. The x min is 0, the x max is 30, like they said. The y min is 0, and the y max is 2000. Okay? And here's my graph. Now, it asked me, find the dimensions that make the surface area minimum. Well, it looks like the minimum would be around here, right? So let's see what the value of x is to make this minimum. How do we do that? Second calc minimum, of course. Okay, and so we go a little bit to the left. It would be about there. Go a little bit to the right. Still going down. Look at the y. It's still going down. Up, now it's starting to rise. So there. Guess. Okay. So it tells me that the minimum point is x equals 14.7. Okay? And then it asks the dimensions that make the surface area minimum. So that means that the bottom of the pyramid would be 14.7 and 14.7, and then the h, the height of the pyramid, would be equal to h equals 4500 divided by x squared. So let's just go to the regular mode of the calculator to calculate that. 4500 divided by x squared. And that gives us 20.8. So the height is 20.8. Okay, so those are the dimensions that make the surface area of the pyramid minimum for the volume given, which was, I think, 1500 centimeters squared. Okay, and so that is probably the hardest problem in the book. That's how you do it.